Okay guys, so today we will be working on derivative of exponential and logarithmic function. In your textbook, I believe it is section 2.6, I believe. And so far we have learned how to differentiate a variety of functions, right? Such as polynomial functions, rational functions, trigonometric functions, etc., etc. But in this function, in this section, our focus will be exploring derivative of exponential and logarithmic function. Similar to how we found the derivative of other functions, we can find the derivative of exponential and logarithmic functions using formulas, okay? The proof of the formula are beyond the scope of this course. But if you need to, if you want to see the proof, then I'll provide this in my lecture note later. Again, the proof is not required for point of view. It's only for those who really want to, see how the how this formula is actually derived. So again, the proof of the formula is not required for this course. All right. If you need to know, if you need a little bit of a review about exponential and logarithmic functions, you can always go back to chapter 1 in your textbook and review a little bit whenever you have time. But I trust that everybody did it at the beginning of the semester. You actually did a practice test, practice exercise that involved exponential and logarithmic functions. So I think you have the basic idea of what these functions are. So here are the learning objectives for today's class. Differentiate exponential function. You will be able to differentiate functions involving logarithms and then apply this exponential and logarithmic functions to solve real world problems. Okay. You know what, I divided this section into two parts. So part 1 is derivative of exponential functions and part 2 derivative of logarithmic functions. So today we will focus our attention on part 1 only. Okay, I don't think we'll have enough time to work on part 2. So today our focus is to find the derivative of exponential functions, and in our next we'll find the derivative of logarithmic functions. All right, so let's work on part 1, derivative of exponential functions. So first of all, what is exponential function? I believe you already know exponential function is it's a function f of x which is given by a raised to power x, where x is any real number and a must be greater than 0 and a not equal to 1. Okay, the number a is called the base. This is a generalized exponential function, but there is another type, natural exponential functions, and I think you have seen these kind of functions, e raised to power x. So we call this natural exponential function. All right, so this one is generalized exponential function. So the idea is that the power, the exponent, is the variable. Remember, this a is a constant and the variable is in the power, in the exponent. Same thing, e is a number, Euler number we call it. By the way, what is Euler number? Sometimes called natural number as well. So it is named after a Swiss mathematician, Leonhard Euler, which is given by this limit. Okay, if we evaluate the limit of this function, e equals limit x tends to 0, 1 plus x raised to power 1 over x. Or you can write limit x tends to infinity, 1 plus 1 over x raised to power x. So which is approximately 2.718, okay, and blah, blah, blah. So this is an irrational number. And to find the derivative, we'll be using this two formula today. Okay, one, derivative of natural exponential functions. So if we have e raised to power f of x, so the formula will be, you just copy the same thing as it is, and then you find the derivative on the top. So this is like chain rule, okay? Exponential rule as well as chain rule. So using this formula, if we want to find the derivative of e raised to power x, then what you do is you just copy the same thing as it is. Everybody know how to copy. And then you find the derivative on the top. So on the top is derivative of x. So derivative of x is 1, so I don't have to write that because 1 multiplied by e raised to power x is e raised to power x. All right? And derivative of generalized exponential function is when the base is not e but something else, we call it generalized exponential function. And the idea is the same. You just copy the same thing as it is, and then you find the derivative on the top. But in this case, you will write one factor extra, that is natural logarithm. So ln is actually natural logarithm of a. So we'll talk about logarithm in detail later in our next class in part 2 of this section. But today, just remember that this one is natural logarithm a, just that comes in the formula. And if we use this formula, then derivative of a raised to power x becomes a raised to power x times ln a, because derivative of the top part, x is 1. And so if you multiply everything by 1, it remains the same. So this is the formula. Once again, those who want to look at the proof, then you can check in your test book, or maybe I can put it in my lecture note later. But it is given in your test book as well. But again, the good news is that is only for your knowledge, but for exam point of view, the proof is not required. Now, with this formula, we are ready to find the derivative of, following function. Let's try few together, and then maybe I'll split you into different breakout room, and then you will work together with your friend. I think that way we learn, you can learn better from your friend as well. You can help your friend, so you will build up a community of learners there in the breakout room, because that's a small size group, and I think you find comfortable talking with your friends. So first, let's begin with part A. So we have y equals 3 e raised to power x. So the derivative is, we are using, okay, 3, this constant remains the same, 3 remains the same. Now we need to find the derivative of this e raised to power x. So we have the formula, look at this, right here. So the derivative of e raised to power x is the same, e raised to power x. Maybe later, yes, thank you, Prabhat, yes. So that's it. Part B, y equals e raised to power 8x. So the derivative is, we will be using, formula number 1. So what we do is we copy the same thing as it is. Okay, everybody know how to copy. And then we find the derivative of the top part. So basically you find the derivative of 8x. So I will write this way. Find the derivative of 8x. And that's going to give me 8e to the 8x. All right. Now let's try part D or E maybe. Let's try part E. Y equals x squared e to the x. Now in this case, remember there are two functions multiplied. So we have to use the product rule, right? So let us use the product rule. This is your u, this is your v, and we know the formula for the product rule is uv plus uv prime prime. So u prime, I know some of you have already done there in the chat room, thank you so much. And we find the derivative of u, which is 2x, and copy v, which is e to the x, plus copy u, which is x squared, and derivative of v, derivative of e to the x will remain the same using that formula number 1, the second one. So that's it. So if you want to do further, maybe you can take x, ex common if you want to simplify. So the remaining is 2 plus x. That's it. Now let's try part Z. No, F. Let's try part F. Y equals e to the x over x cubed. And you know what formula we'll be using, right? So this one will be, actually it's we'll be using the quotient rule here. So your derivative is going to be, you know, the formula is uv minus uv prime over v square. So that's gonna give me u prime, which is e raised to power x. Derivative of that will remain the same, and copy v, which is x cubed, minus copy u, which is e to the x. So find the derivative on the bottom, which is 3x squared over b square is x cubed squared. So that's gonna give me, you can take e to the x and x squared common in the top if you like, or let me write this way, maybe x squared and e to the x common. So the remaining is x minus 3 divided by x to the power 6. So if you want to simplify further, you're going to get e to the x, x minus 3 over x power 4. Okay, Prabhjot, thank you so much. And yeah, so this will be, the final answer. Any question, guys, so far? And let's try one more, part H, which is y equals 4 raised to power 3x. Now this is a generalized exponential function. Okay, so the generalized exponential function, we have the formula. Let me show you the formula here. So this is the formula number 2, as you can see. So the derivative will be, copy the same thing as it is, find the derivative on the top, and then just one factor extra ln h. So the answer for this will be, copy the same thing as it is. Remember, the formula is d over dx of a raised to power f of x equals, here is the formula, copy the same thing as it is, find the derivative, and ln a. So this one is the formula. So that means copy the same thing as it is, and derivative on the top, which is derivative of 3x, and then ln a is 4 here. So your answer is going to be 4 raised to power 3x ln 4. Or maybe you can write this ln 4 here. Yeah, it doesn't matter, ln 4. All right, yeah, you can write this way. Any question, guys? Okay, so we already know how to find the derivative of both type of exponential functions. One is natural exponential function, another is generalized exponential function. Now the question is there any application? Why we're learning all of these? Can we apply this in the real world situation? The answer is yes, of course, right? So we learn mathematics because it allows us to solve our real world problems. So let's look at few examples, simple examples, all right? Okay, maybe I'll do example 2 and I'll leave example 3 for you guys. Okay, so example 2. A principal amount of money of $10,000 grows continuously at an interest rate of 4%. Find the rate of growth after 4 years. Okay, now first recall continuous growth formula. Okay, recall the formula. Continuous compound growth. Recall from pre-calculus, which is given by A of t equals PERT. Do you remember this formula, guys? Where A represent the amount, P represent the principal in this case. Here, P is the principal amount, which is 10,000. R represent the rate, in this case 4%. You can change it into 0.4. All right, and T is given 4. We'll write that T here. Now, let me write this down. So our changing this statement into mathematical statement, mathematical equation. So our equation will be A of t equals P, substitute the value of P, which is 10,000. E, R is constant. T is variable, okay? T is variable. T is time in year, which is a variable. So RT, so R is 0.04 T. So that's our mathematical model for that situations, okay? Now, because we want to find the rate of growth, we know that rate of growth or rate of change is basically the derivative, right? So let us find the derivative of this. A prime of t is going to be 10,000, remains the same, and derivative of this part will be just copy the same thing as it is. And then you find the derivative on the top, which is 0.04 t derivative. So this gives me, if I multiply 10,000 with this 0.04, I'm going to get 400 e raised to power 0.04. Maybe I'll write this way. I'll just write 10,000 as it is right now. 10,000 e raised to power this, and derivative of that will be 0.04. So your final derivative, simplified version, will be 400 e raised to power 0.04 t. So this is our derivative. Now the question is, we need to find the rate of growth after 4 years. So after 4 years, that means your t is 4. A prime of 4 equals 400 e raised to power 0.04, and t means 4. So can you help me? What is the final answer here? You can put your answer in the chat room. Okay, guys, so we got $400, 469.404. But remember, this one is a, it's a real world problem. So in general, what we say is that mathematically this is correct, but in general, we say that it is $469, maybe 40 cents. I just write 40 then. Okay, so this one, and what is the unit here? Dollar. What is the time? Per year. So unit is important. Okay, so this one is per year. Okay, so that is the growth rate. That's the derivative. That's the growth rate. Any question, guys, so far? So if you don't have any question, what we're gonna do is I will split you into different groups. So you will go into the breakout room and you'll be working on example 3. I believe you have the handout. If not, it's already there in the canvas. So you guys will be working in the breakout room. I will come and, observe you working in the breakout room. If you need help, then I will answer. I will help you as well. So now your job in the breakout room is solve this example 3. If you need, you can actually take a picture, or it is already, the handout is already there in Canvas, so you can actually download from Canvas. But I just in case, if you want to take a picture, it is there.
So do we have access to for the test question answers?
Yeah, we'll talk about that later after we are done with this.
Okay.
Okay, now let's go to this one. I think we have done few of those, and we have done A is done. Okay, A is done. B is done. E is done. F is done. So you are left with these guys here.
H is also done.
H is also done. Thank you. Okay, so you will be working on the these 3, and then example number 3.